So I've been doing this for a while now. I have an answer. Is it the right answer? Let's try it out. Holy shit! I did it. I got it. So now let's explain it. Hello everyone, I am Bradley Sward, and this is my Day 21 Part 2 solution for the Advent of Code 2024. The problem is called Keypad Conundrum. The problem is solved, almost as always in my case, in Python. So I am an absolute master of Part 1 by now. I have solved it 4 separate ways, trying to figure out how to get Part 2 to work. The 4th way is the way that I can get it to do it, and I'm done. I am done. So just as a reminder for anyone else who hasn't put in a ridiculous amount of time into a useless fun problem over this holiday break, you have a keypad, you have a robot that needs to touch the keypad. You need to move the robots around. There's 3 robots. You are controlling a robot who's controlling a robot who's controlling the robot who needs to press these button keys to touch that one, and then press in like a 4-digit code. Either it's I can't remember anymore. Is it a 4-digit or a 5-digit code? It always ends in A for whatever reason. It's all fine, just whatever it is. And so I think I'm going to have this thing tattooed onto my arm or something at this point, because this is just a memorable experience, to say the least. So from there, you're like, well, let me just map out what I need to do, because if I did all this in one, this is like step 1 of the whole problem, was to do this. And then from there, I was like, well, if I need to go on this map, if I need to go from A to A, I just press. If I need to go from A to up, well, I got to go left, and then I can press. And you can kind of see how this is going. You can see this is the keypad here that represents that. And just to show, just through here, you know, well, okay, like, I was like, I can figure this out mathematically. And you're like, that's cool. It only takes one press to do, or one operation, or 2, or 3, or how many operations does it take to go from wherever you are to go press the button wherever it is you need to do. And you're like, well, there's a simple grid, and I'm just figuring out, oh, it should take about 10 billion different commands, especially for part 2 when there's 25 robots. Oh, was I absolutely wrong? And like, well, first, if I can do this for 1 step, well, then I can do this for 2 steps. And so I wrote, you know, it took time, painstaking, and again, all of these things work perfectly fine for part 1. Like, this works perfectly fine for part 1. This works perfectly fine for part 1. What else have I got here? Here's me writing it out. This is just becoming hieroglyphics, and the insanity is setting in. And then, like, at this point too, like, you know, like, everyone is like, leave me the fuck alone. Like, just please stop talking about this stupid robot. But I have dimes, and I'm moving things around, and I'm trying to figure out, how do I get this? Why is it not working the way I want it to work? But anyway, coming back here. So all of this technically works, but it doesn't work as you move from 2 to 3 to 4 to 25 robots. I still don't know why. I don't necessarily care anymore. I have my solution. I'm giving up with life here. But anyway, so coming back. So that's how we can do things. Just to show real quick here, so you can see that I still get my part 1 solution with this new methodology, which I'll explain in a second here. But for part 2, there's nothing more in the information that they gave us. They're just basically like, there's go from 2 to 25 robots, go. And from the program description, they don't describe anything that could go wrong. And maybe your fun is different than my fun. And this went from being fun to being a compulsion long ago. And so just saying, like, well, yeah, I get that, you know, some go, you know, some require less presses than others, but there was nothing to indicate that there were like fringe cases or edge cases that could cause issues. And that's what caused a huge amount of overwork and rework to get the solution to the problem. So anyway, so for part 2, you can see I already, you know, hear me swearing. Oh, actually, why doesn't this? Wait a minute. What? Why doesn't this give me credit? Why isn't this giving me credit? Maybe it's because I had this. Yeah, there, I do have 2 key. There we go. Okay, just to prove I do have it. Okay, so there's my solution. There's my answer for part 2. So let's take a look at the actual code behind it. Logically high level, it's very easy to understand. Again, like, it's just the fact that we can't conceive of all possible paths and 900, literally 900 billion commands that would need to be commanded to make robot 25 tell robot 24, blah, 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 all the way down to tell robot 1 to go press all the darn buttons. Okay, so let's see. So that's that. So my code is as such. Okay, so I have the numeric keypad. I give them a grid system, the same with the directional keypad system. So that is a duh. So I'm generating, every time I'm going to generate things, instead of trying to figure out how to do things when it comes to just setting up like lists or something like that, basically I'm going to set up a dictionary of, I'm going from this state to that state. What do I have to do to make that happen? And it's basically a dictionary. It's a map, just like for how many times do I need to go and press this button to make this work? Because in the problem, it never describes that you actually have to keep track of the actual command that you're trying to give the robot, which goes against, like, okay, it just goes against the problem in my understanding, because it's like, wouldn't it be nice to know what the robot is actually supposed to do? But no, we just only care about how many commands it takes. Like, whatever. It goes against the immersion of the problem or whatever. But anyway, so here's the generate new frame, and then from that I can say from a specific command I can generate the frame from that, like, starting from A, I need to go to up, and then I got to go left and whatever, and it will generate basically there's a 25, there's 25 separate elements to each of this. And I could have sped this up greatly if I just eliminated all the zeros, but I don't give a flying hoot anymore. It takes about, let's see, on my computer downstairs, it takes about 4 hours. This computer up here, I don't know, because I just got the computer downstairs, probably about 8 hours. I don't care anymore. Like I said, I generated a solution. I was genuinely shocked that it worked. But anyway, so now I stole this from what is that place called? Stack Overflow. How do I generate a power set from a specific, basically, how do I set up all the permutations of something, minus the actual permutation of it being empty. And so from this case, maybe I don't need whatever anymore. So this is the generating the power set of possible button presses. And so now I'm turning this code here, and again, I probably could have simplified this greatly. I'm just trying to figure out from every position that I start from to every position that I need to go to, what are the possible button presses that I would need to do to make that happen. And let me just show you. I could put a breakpoint in. Let me stop this since it's gonna take forever and a day, and just run this. And you can see that my numeric keypad map is basically a whole bunch of craziness here. And now it says here that if I want to go from 7 to 7, I just press A. Like if my finger is on 7 and I need to go there to press 7, I press A. If I need to go from 7 to 4, well, I just go down and then I press A. And you can see this is where the fun is. It's like, well, there's many different ways. In this case, there's 6. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different ways that I can go from 7 to A. And in my haste, I guess, if you want to call it, over the week here, it was basically saying, well, I just found which one was the best, and that was the problem, because you can't, for whatever reason, you can't just say this is the best always. You can from 1 and 2 robots deep, that's perfectly fine, but when you get 3 or 4 or beyond, or whatever the magic number happens to be, you can't work with that anymore. So that's why all that work that I showed earlier won't work anymore, is because I need to test every one of these possibilities, and then basically advance from there. And when I find a better one, then find a good one that's better than the others, well, I'll use that. And the same thing goes for the directional keypad. So let me just and I set up a whole crazyville here. So let's see. So oops, I get rid of that, and then whoops. Yep, from here. So now I have the keypad map. That this is totally different, because step 1 only needs to be done 1 time, and I already wrote the code for part 1. And again, I don't necessarily care. I'm not looking for the fastest solution. I know what I need to do, but I know how I would work on it now. But this is to say, if I need to go from down to down, I would just press the A button, right? So that's how that goes. And again, I could have eliminated all of these zeros, and this would have went a lot faster when I run the code, but I don't care anymore. So then that's the map. And the thing is here, for some of them, there are 2 different ways. Coming back to this visual here, there's 2 different ways to do every one of the ones in green. And that's where the fun begins, because that means if there's 2 possibilities for every one of them, there's 1, 2, 3, 4, 5, 6, and there's 2 possibilities for each. Well, there's 2 to the 6th power, or 64 different ways I could test any one command. And so one command in the next realm could be 64 commands. And then what is like you want to go crazyville here. What is 64 to the 25th power? And I did press a 6, I don't know. 24, oops, that ain't it. Hold on, oh, goodness gracious. I got a new mouse and a keyboard, so I'm like trying to learn how to work with it. It's just not working, there we go. So 64 to the power of 25 is that number, which I know moles. I know there's a lot of molecules in a mole. 6.022 times 10 to the 23rd. That's a ridiculous number. We can't keep that number in memory. That's why we have to cull the list of possibilities. We want to keep the best. Well, anyway, coming back. So then my power set here is all 64 of those possibilities. So I took this directional keypad and I generated all 64 different ways it could go, picking this one and that one and all the other ones for those 6 things. So there's my power map. And then here, through my power map, I just go ahead and I just removed whichever one needed to be removed so that they're all unique. All 64 different ones are unique because I basically copied the thing 64 times over. That's why it's a deep copy here. And then I eliminated the specific ones that needed to be eliminated so that my power map consists of 64 separate ways that I could test any command. So then now, coming back down here, this is, the rest of it is relatively simple, all things considered here. How long have I been blabbing for? 11 minutes already. Whatever. I'm having fun getting this thing done here. So anyway, so basically you generate the first robot. Here, let me just show you what the thing generates here. And you go, oh, there you go. So I have 6 different ways I could generate, which, here, what is the line I'm trying, this one here, 671A. There are 6 different ways I could go just off the bat to get the thing to touch, to make it happen. And so that these are the actual dictionaries that make it happen. But for the next step, well, this is where the fun begins, right? Well, now I need to go through, but this is my first code here. So what does this thing generate, right? So this thing generates the codes one by one by one. It figures out all the possible ways, and again, in this case, it figured out that there's 6 different ways it could do things. Yeah, let me just go through one more time here. It takes a couple seconds to generate all my nonsense, at least on this machine. And then from here, so my commands are that, right? So exactly the same as you saw before. So I need 1 of these and 1 of these and 2 of those and 1 of those and 4 of those. And again, it doesn't matter, the list doesn't matter. I just need to figure out what I need to do. So now for the second robot and the third robot and the fourth robot, they all follow the same code. Look at that. It's not even a lot of code here. This is craziness when it comes to a dictionary, the first element, because I was too lazy to fix it, and then inside of there, get an element inside of that, and then multiply things around and do all sorts of stuff. But the key here was basically, well, if I'm left and I need to go right, well, I need to do whatever commands I need to do, and I need to generate that, and I need to generate a brand new map, basically from everything I'm going, and then look through all the steps to figure out, well, I need to add this, I need to add that, and basically I need to do this 12 times, and 12 and 22 times of this one, and 22 of that, and 19 of this, and so that simplifies things to, at least down to something that is manageable. I know how to fix this up and speed this thing up greatly, but it doesn't matter anymore, to me anyway. And so this is the code that generates that. So from the 6 commands, just to say from the 6 commands that come in, and just to say here, like the inputs, I have 6, here's my 6 robots, and I go, when I get down to here, there's going to be 6 times 64, there's going to be 292 or whatever different elements when this is all said and done. And that takes a while, but there's going to be, 292, 384, whatever, I can't do the math right. 6 times 64, yeah, 6 times 64. I was thinking 384 different ways to go, and I'm like, well, some of them are going to be just as good as others. We're only looking for the shortest one. We're not looking for all of them. We're just looking for what's the shortest. But you can definitely see very quickly that 300 becomes thousands upon millions upon billions upon trillions upon moles upon half the particles of the universe to figure out the different ways that this could go down. And so basically, it worked for me was to basically say, no matter what, at every step of the way, basically sort out by like how many different values there are. So the smallest steps are basically at the front of the list, and then only keep the first 10,000 of them. I could see this being a huge problem also, but it didn't work. It didn't end up being a huge problem for me, so it got me the solution. And so when you run that, and again, you can see that it does run, where is it here? It does run the solutions to the first, oops, this is way back in the past here. But, as I go here, as we go through step one, again, it takes quite a while, even for part one, because it's just generating thousands upon thousands of things, and it requires 600 multiplications when I could have probably reduced it down to about 10 or 12 at the max. So I could have really reduced this down to like 2% of the work. Oh, let me get rid of this. And you can see that, this is going to generate my part one solution of 163,920 or whatever it's going to end up being. But anyway, so through all of that, anyone here who's still watching this, you deserve a prize, but I just wanted to preserve for posterity that I solved this problem, and it took me forever, but I figured it out, and now I'm ready to move on to part 22 here. Day 22 hopefully will be easier. I think it will be. But anyway, I'll let this thing run. Yeah, it's almost done here. But if you have any questions, I don't want to know any better ways at this point. So if you want to put them in the chat for anyone else or the comments, please go ahead and do so for anyone who cares. But thanks for sticking it out with me as always. Those of you who do watch my videos, or any of you who do care, it is always greatly appreciated. So hope to see you in future videos. Have a great day, everybody. Take care, and I'll see you then. Yeah, there it is, 163,000.